välkomna till lite återstarten på Humlegarden och Fermentis webbinar. Just nu är dagens talare, han är lite indisponibel. Han kommer väl alldeles strax in här. Då kan jag ju köra lite praktiska grejer på svenska då, innan Gino är tillbaka. Ni kommer att kunna se det här webbinariet i efterhand om ni vill det. Ni kommer få en länk mejlad till er. Vi samlar även både länk och själva presentationen på vår hemsida kan ni hitta. Där vi har samlat även de tidigare webbinaren som vi har gjort. Så där finns både presentation och länk till själva inspelningen av webbinariet. Bra att veta om ni inte har sett dem tidigare. Det funkar nämligen sådana programvaran att man måste vara anmäld till den. Det är den registreringen som gör att man kan hoppa in och se den igen. Tyvärr så har vi inte hittat något sätt att kunna se dem tidigare om man inte varit anmäld till dem. Vi får se om vi kan komma fram till någon lösning på det framöver. Men i dagsläget så måste man ha varit anmäld till själva webbinariet för att kunna se det även i efterhand. Ni får jättegärna ställa frågor löpande under själva webbinariet. Enklast är om ni gör det via chattfunktionen. Hello Gino, you're back.
Hi, I'm back. Just a quick
I did a short presentation or introduction in Swedish when you.
Oh, great.
So, as I said, you're able to ask questions, preferably via the chat function. You can do it either in English or you could do it in Swedish, and then I interrupt Gino and do the translation. So either way, that's suitable for you. So welcome back, Gino. We have had a summer vacation, hopefully. How have your summer been?
It was too short, as always, but we had we had great weather, and obviously because of the virus, we had to stay in the country. At least that's what they advised. So I went sailing on a sailing trip, actually on the northern side. On the northern side, we have some islands, 7 islands, I think. So we did 4, and then by a historical clipper, we sailed from one island to the other. And it's called
nice.
It's called the Waddenzee. So it's a sea, and because of the tide, the sea completely disappears. Sea for like 8 hours, which is nice because then you can get off the boat and find food on the bottom of the sea, like mussels and clams, and that's what we did actually. Clean them and then cook them and ate them. Obviously, with a lot of nice beers involved.
Yeah, of course.
So
and
that was nice.
That you have brewed by yourself?
Yes, actually, yeah. I've brewed now 6 beers during the crisis. Not all of them are as expected, but some of them are quite good. Actually, 2 of them I put in for the national competition, so we'll see where I end up. Yeah.
I thought from the beginning when I thought that I should have more time brewing beer during the corona, but so far I've just done 2, so I'd expect a little bit more. Yeah, unfortunately. Hopefully maybe to the weekend there will be some brewing.
Nice.
So if I find the time.
I see on the chat actually that I'm wondering if people can hear us. Can just somebody say yes or no? Okay, perfect. Thank you, Martin.
Okay, good.
So we are now with the 27 people in total. 57 people subscribed, but I think we can start anyway. And then
I know we have got some comments to our customer support today, and people wondering how this working with looking at the webinar afterwards. But so we have told them that you have to reply for logging to be able to see it afterwards. So I think lots of people webinars, and maybe this one as well. Is there any way for them who have not signed up for it to see it anyway, or?
I don't know. I think you have to try to sign up then. I'm not sure.
Because maybe some of the people here today want to see the earlier webinars if they haven't been able to do so.
The only webinar that got lost, I think, was the one on New England IPA. Because then we had a restriction to only 100 people. And so to be able to change that, the webinar had to be destroyed, actually. I don't know why. It's a technical issue.
Okay, that's a pity.
But I can redo it if people want that. I'll show you. I don't know if I can show you. Go backwards. No. So let me see if I can jump to the end.
Yeah, we could look into that later on and see if.
So let me. Yeah, this is the end. So the slide before the end is this one. So for the crowd that is here now, I have scheduled 9 webinars. We already did 2. So the impact of temperature, pitching rate, and original gravity, and the best yeast for New England IPA. But the normal order, the reason that we started because Jonas and Humlegardens was able to start quickly, but I didn't really have a program back then. So this is already like 2 months ago now, I think.
Yeah.
But now I actually have a program which is more logical in order. So the idea is that we do a webinar every week. And this webinar of today is actually normally the first webinar in the cycle. It's, as you will see, it's all on the production, the quality, but also the shelf life. As all my webinars, it contains actual scientific data. Because that's what I like. I'm not too much into sales talks, although I am a sales guy, but I'm also a scientist. So the cycle, which is more logical, is shown here. And if people want, I can redo all of them. But I don't know what you think. I know this one, number 3, is still available. It should be available, so you can check that. It's recorded, but this one got lost. I'm quite sure about that. So this is the idea, and then as you will see at the end of the webinar, there's also room for input of your topics and ideas. And the idea is for the second half of the year that I collect all these subjects and do some study on it, literature study. Like one thing we discussed and came up after the first 2 webinars was the impact of counter pressure on yeast performance and flavor development. That's something that I'm working on now. So in 9 weeks or in 10 weeks, I should be able to come up with a proper presentation on that subject. But if you have anything else, yes. If you have anything else that is interesting, just if you fill in our form at the end, I will know, because all your comments are collected in one form, and then I can check, what's most interesting for you. So I'll go and start. Back to the start. So this is just explained by Jonas. So if you want to come in live, actually, that's also possible. Jonas can also give you access, so everybody can see you or hear you, if you prefer to be live in the room. The reason that it's restricted is because if we are with more than, I say, 10 people in the room, it's already quite noisy. So that's why we work like this. So let me just start out quickly. This is a slide you will see in every webinar just to explain where we are. You are in this beautiful country, in Sweden. Unfortunately, I'm not allowed to travel there, mainly because of this region, Gothenburg. It's still red in Holland, so I'm not allowed to travel there. If I travel there, I have to go in quarantine for 2 weeks. So that's why we don't travel. We are actually based in Lille, which is here in France. Do you see my cursor or not?
I can't see your cursor.
Let me try to. Yep, should. Yep, you see it now? The red dot.
Yep.
I'm at Stockholm here. Okay. So we are here in Lille, which is just across the Belgian border. It's a beautiful city. If you have the opportunity to visit, please do. They have a fantastic beer lineup, mainly because of the country next to it, Belgium. All the Belgian beers are available. Our production facility for the brewing yeast is actually in Belgium. It's in Ghent. It's behind this spot. This is a picture of the factory, and today, obviously, I will explain all about the factory, so I can continue. This factory is not only making yeast for beverages, but also for bread, for spirits, for ciders, for wine. In total, we have 63 production facilities. Most of them are only dedicated to bread yeast. And the facility in Ghent is mostly beer, wine, cider, spirits. So that's the world that we work in. As you will see, it can produce very high quality. Some of the wine is produced elsewhere in the world, in South America. It's a bit depending on where the wine growers are. So in total, we have 63 factories. Today, I will talk about yeast. I will talk about yeast in the most of my presentations. But I will also talk about bacteria later on in the webinar cycle, and a bit on yeast derivatives or fermentation aids. For now, that's not really relevant. So what is yeast? It's a sexual organism. In one of the presentations, I can go in more detail on the sexual reproduction of yeast. A lot of universities, but also companies use this to bring specific traits of an organism, of a yeast in another yeast, just by, allowing them to have sex. So that's, they have sex, you screen the offspring, and then you select your favorite strain from the offspring to create a new yeast. In nature, it's estimated that there are around 200,000 species, but industrially, it's way less. It's a few thousand, and actually in production, commercially, it's only a few hundred strains available. So what do we have at Fermentis? So 2 types of yeast, sorry. Saccharomyces pasteurianus, so the bottom fermenting yeast. For lagers, it's typically cold, it's typically slow. And then we have top fermenting yeast, which is typically a warm environment. My computer is doing a bit strange, sorry. And it's typically quite fast. So within days, you are able to produce a beer. Or say within a week if you include and do short maturation. Practically, normally a few weeks, say like a week or 3 weeks or so, you can be done with an ale. Lagers take more time because usually it's fermented at lower temperature. But as I showed in a previous webinar, you can also do this quite quickly at higher temperature. So what do we have at Fermentis? My presentation is quite slow. It's jumping a bit. Oh, come on. Maybe the file I uploaded is too big for this platform. Anyway. Ah, come on. Now I should stop clicking. So at Fermentis, we have, I don't know why it's so slow. We have 14 yeasts now in our portfolio, 3 lagers, and then 11 ale yeasts. Some of them are called SAF ale. So this is basically our traditional portfolio that has been established already for many years. We have one yeast specifically for bottle re-fermentation, F2. And then we have the SAF brew range, which is actually a range that is very different from our standard range. LA01 is a low alcohol yeast to produce non or low alcoholic beers. And then we have HA18, which is a yeast enzyme complex. So all the yeast that don't fit into a standard kind of yeast is put in the SAF brew range. And then we have one bacteria now.
Sorry to interrupt you, but the soft brew isn't available in consumer packaging yet.
Indeed. LA01 will probably never become available because this is a maltose negative strain, so you have to be able to pasteurize. And most homebrewers cannot pasteurize, or if you pasteurize, what I would do is put it in hot water for a certain time, but you need to put it in hot water for quite a long time to reach the temperature of at least 60 degrees, and it will not be good for the flavor development in your beer. So you have to have like a tunnel pasteurizer, which most of us or none of us will have as smaller craft brewers. So and then HA18 is a yeast enzyme complex, which is different because it's 50% yeast, 50% enzyme. And this one might become available in smaller packs. I'm not sure yet. Okay. It's always, these things are decided by our marketing department. So if you look at the diversity of this range of yeasts, I hope my slide will change. I'm showing here a phylogenetic tree. So what is a phylogenetic tree? This is basically indicating visually how related the yeasts are. So if you want to have a wide portfolio of different yeasts, you have to be able to separate these as much as possible. To give you an idea, here is SAF Ale SO4 that you use quite a lot. It's a quite neutral yeast with some fruitiness, and in the same clade you have USO5, which you all use a lot, also quite neutral yeast. This is flocculating not that well. This is flocculating very well. It drops out very fast. So if you look at this, is a slow yeast. This is quite fast yeast. So the differences genetically are all in these aspects, but they basically cluster in the same group. Similarly for the other yeasts, some things are kind of obvious, like F2, our bottle re-fermentation yeast, actually it comes from the wine clade. So it's specifically focused to consume simple sugars like glucose. That's why it's not in the beer clade, and so on and so forth. So these are just to indicate that we have quite a nice genetic diversity, which obviously also results in a nice diversity physiologically. So different flavors, different fermentation characteristics. So what do all these yeasts have in common? Obviously, they all make alcohol. So, and if you really simplify the yeast metabolism, that looks like this. So you consume glucose, you enter glycolysis, and then the ethanol pathway to produce ethanol. On the side, you produce also CO2, as you know, the bubbles in the beer. And if you keep it very simple, it's about 180 grams of glucose. You convert 50-50 in ethanol and CO2. Obviously, you also produce heat in this reaction. Energy is dissipated. This is ATP. But if you really bring it down to an actual situation in your wort, in your fermenter, then you can better look at the Belling equation. Belling is a guy that did a lot of applied research on brewing, and he came up with an interesting brewing equation. I think most of you guys know this. So if you look at then this is the typical Belling equation that people use. 1 kilo of sugar is converted into 484 grams of ethanol, 463 grams of CO2, so almost 50-50, but also a little bit of yeast. So during fermentation, you also make yeast. It's normally about 5% of your sugar gets stuck in yeast. So if you look further, a bit more detail in the yeast metabolism, you start with malt or combinations of malt and other stuff, syrups, whatever you guys do. You mash it normally, and then you create fermentable sugars. A typical composition of the wort is about 10 to 15% glucose, massive amount of maltose, the majority, 60%, then some maltotriose and dextrins. And depending on the type of malt and the modification of the malt, this can change. So you have highly modified malts that are very high in or higher in dextrins, for instance, or can be lower in glucose. What you do then is you ferment and you create not only ethanol and CO2, but most of the times also some glycerol, which brings the mouthfeel to the beer. Some acids, these can be different depending on the yeast. Some lactic is possible, sometimes acetic acid, succinic acid, typical organic acids that are close to the citric acid cycle. You also create biomass a little bit. This is only 5%, so the majority goes here, then a little bit here, a little bit here, a little bit into biomass, and a very little bit into aromas and flavors. And you also only need a little bit to get it, to sense it in your beer. So this is, if you start with 1 kilo here, this is also in the this is in the like half a kilo range. This is in the like maybe 100, between 20 and 100 grams. This is in the grams range. This is in the grams range, but this is in like ppm, ppb range. So very low microgram range. So if you make a mass balance over the whole system, nobody considers these aromas and flavors, because the amount of carbon that you put in here, that goes in here, is neglectable for the carbon balance, but actually not for the flavor balance, obviously. Most of the times you will also have some residual sugar. So typical yeast, like your SO4 or USO5, they have an apparent attenuation of around 80%. So if you start at say 12, 13 Plato, you will have residual sugar of around 2 Plato, which are mainly maltotriose and the dextrins. As mentioned, this one is the most relevant for beer because, to my opinion, the yeast brings the spirit in the beer. And if you look a little bit more closely to this yeast metabolism, it becomes a little bit more complex. So in this case, on this slide, you start also with the sugar. You go through glycolysis, make pyruvate, and from then you start splitting it up into different compounds. Some of them are very desirable. So, the first one is going to ethanol. Of course, that's what we want. Sometimes you want some green apples, sometimes you don't. In most cases, not actually. Most people want these kinds of flavors. Banana, like isoamyl acetate, ethyl acetate, which is the more solventy flavor, floral flavors, sometimes fatty acid flavors, star anise, apple. 4VG is a typical flavor that is produced by POF-positive yeast, so they are phenolic yeasts. Typical, if you are brewing a Belgian style wit beer or a German Weizen, some Belgian blonde beers, this flavor is very desirable. So based on that, you can select the yeast that you want to brew, or to get the flavors that you want in the beer. And in other webinars, I go in more detail on how that works. So obviously also off flavors are produced, but we want to prevent that. So to make a little bit of sense of the options, what we do at Fermentis is we provide so-called baseline fermentations to compare the yeast, to give you an idea on, okay, I want to make a fruity beer, which yeast should I select? Well, we position in this slide, we have 3 axes: fruity, spicy, and neutral. And based on sensory analysis of all these fermentations, and these were all done multiple times, we position the yeast in terms of these 3 flavor descriptors. All were done at 15 Plato with iso-alpha bittering, so no hops addition, but only iso-alpha extract at fairly low 25 IBU. We pitched all of them at 50 gram per hectoliter. And the temperature for all these was 23 degrees, no counter pressure. So 23 degrees, quite high for lager. That's why some lagers get more fruity. As you see, S23 gets more fruity at higher temperature. That's why it's here. Normally, you would expect that it would be quite neutral. So we have some things online on our website. You can download all this to see, okay, if I want to brew what style or this spiciness or this fruitiness, which yeast are good candidates, at least for your beer. We also have a book called The Tips and Tricks. I'm not sure how much of you guys know we have this. It's quite an extensive book. I'll just check how many pages. It's 52 pages actually, with all kind of information like fermentation kinetics, alcohol tolerance, ester development, you name it. What we know, or most what we know of the yeast, is in this book. Normally we provide a yearly update, so if new things are found, new flavors, or if you have a new yeast, it's normally added in the next edition. Traditionally, we launched this tips and tricks book at Brouw Beviale, but I'm not sure if that's going to happen this year. You can download it here on our website. And most of your questions will be answered. Now, come to the actual presentation on the topic. This is our production plant, just to give you some idea. So the entrance is here. Here you have like a more office type of building also here. And this is the actual fermentation building where you have huge fermenters. I will show a picture later. Obviously, we have a big storage facility to store our substrate, which is molasses, but also other things that go into our wort, I would say, to produce the yeast. We also have a big wastewater treatment plant, like normally all big factories have this. And this is all packaging, this unit. It's situated on the canal from Ghent to Terneuzen, so everything is supplied by boat normally. Once a year, well, with the virus, I'm not sure, but I would say maybe once every 2 years now, we organize visits to the factory. And well, when it's time, you can subscribe and come over to Belgium, visit the factories, and see it with your own eyes. Now I only have a simple.
I can recommend it. I've been there.
Yes, because there's also a lot of, product involved: beers, wine, spirits. So it's those gatherings are really nice. I can really recommend it. For now, I just have a simple slide of our production process. So it starts all in a laboratory in the safe at the -80. We store our yeast. In total, actually, we have a yeast collection of about 8,000 yeasts. We have 200 yeasts now in production. But we still have 7,800 yeasts that have not been used before or for anything. The reason is that before we start producing, we need to see additional value to the current portfolio. So we only bring a new yeast to the market if we feel that it brings new flavors or new specific characteristics or new, very fast kinetics or no off flavor development or whatever characteristic that we are looking for. That will go into production. All the others will not. So that's very different from, for instance, liquid yeast. But I will come to that later. So from that, we start culturing, first in small test tubes. So this is like milliliters. Then we go to the next one, a Vanica flask, which is like, a few grams of yeast is inside here. We propagate further on to Carlsberg flasks, which is a few hundred grams. And with this, we inoculate our first fermenters. It's like the pre-fermentation. We can produce a few hundred kilos of yeast in this system. Then we go to the next system where we produce a few tons of yeast in one run from, like, say, 3 to 5 tons, depending on the yeast. So typically, lager yeasts have a way lower yield. So we produce around 3 tons per go, and ale yeast around 5 tons per batch. All this is done under sterile conditions. Except from this step onwards, we cannot supply sterile air. So we do a deep filtrated air, and I will explain later what that means for the exact purity of the yeast. We can go on to bigger tanks if we want, depending on the factory. In Ghent, we can actually to tens of tons. So you can make maybe 50, 60, 70,000 kilos of yeast in one batch. So it's quite big. Once that's done, so I'll explain later what exactly happens in these tanks. You go to separation. So we separate with centrifuges. Obviously, the spent wort or spent molasses in this case is going to the wastewater treatment plant. And the yeast is stored as a cream, so it's yeast that is concentrated. We have several storage tanks, and that's because the capacity of what is behind is not as big as we want it to be. So we have to store it, but this is very short. It can be like 1 day or something. And as you will see, it will not have any. It does not have any impact on viability or vitality. But I will show those results later. From that, we continue to a rotating drum filter, and I will show you a picture of that. To an extruder to cut it up basically into blocks. This is, in our case, it's fresh yeast, but we don't have that in our Fermentis portfolio. What we do is we go to the dryer and we dry the yeast and end up with a pack of dry yeast. As you can see, we also produce liquid yeast, but this is mainly for big bakeries. And there's a truck here, and actually some bakeries use 4 or 5 trucks per day. So the big industrial bakeries use a lot of yeast. We prefer dry because I will show you later there's no difference. And if you dry it, you have a lot of advantages, especially logistically. But I will come to that. Just to show you a picture of the fermenter, one of the big ones. So this is an actual fermenter inside the factory. This one is 200 cubic meters. So it's a big one. It's maybe comparable to the big fermenters at big, large breweries. The lager breweries, they have tanks like this also. The big difference is that we put in air because we don't want to produce ethanol. We want to produce biomass, and the air that is going in is tremendous. If you see the scale of the compressors needed to blow in the air, that's quite impressive. I also have a picture of the rotating drum filter. I cannot show everything from the factory because especially the drying part is top secret. It's unfortunately something I cannot share because we are quite good at that. And if the competition sees it, you know how it works. So let me check. Did I now jump a slide or not? Okay. So what happened is I will show the rotating drum in the next slide after the one that is coming now. I will show you what actually happens in this fermenter schematically. I don't know why this it's going so slow.
We have a question here from Jeff. Do you have any problem with the pressure in billeting growth in the largest tanks?
No, because
okay, that's a quick one.
Yes, because if you have a big tank like that, you would expect a very high hydrostatic pressure because there is a lot of meters of liquid on top, but we blow in air. So, and it's a lot of cubic meters per minute that go in. So in the end, I think the yeast is most stressed by the hydrodynamics. So the actual force of air going into the system, than the pressure from the liquid. There's no pressure issues in our production tanks. It's very different to brewing because brewing is static. So what you have is a huge tank, you put in the yeast and you don't do anything. You don't stir, so all the mixing and all the transfer, of sugar to the yeast is all going like in a diffusive way. We are lucky that yeast is producing CO2 because that actually causes the mixing. If a yeast, shits out a CO2 bubble, that's basically what happens. This CO2 is lighter than the rest. It's gas, so it starts floating to the top, and on the way, it leaves some space. So that's where the yeast will go. So you have, a more diffusive mixing in a big industrial fermenter, and because it's that slow, you will have more impact of the hydrodynamic pressure, that is caused by just the meters of water column or wort column on the yeast in the bottom. Well, it's very complex. That's why I didn't give a webinar on that, because the whole hydrodynamics in an actual yeast fermenters have only been studied, very briefly. We know it works. But in some, and we know that the big ones are using, these big fermenters, and they produce most of the times neutral beer. So we know that it has impact on flavor reduction or less flavor production in these big tanks. But how exactly nobody knows exactly. It's also depending on the yeast. So I need some more time to come up with a good story on that, and I need to read quite a lot of literature on it before I can say anything more like, relevant on it. So let's go back to the propagation. What happens in these fermenters? So this happens in all the fermenters, from the small flask to the big production fermenters. Is we start, and this is the cell cycle of yeast. I don't know if you all heard about the cell cycle. So you have we display here 4, but actually you have 5: G0, G1, S, G2, and M. So we start with a single yeast. The yeast starts budding, so it's actually replicating, and then it goes from the G1 to the S phase. So the S is the synthesis phase. It starts synthesizing more DNA. You enter the G2 phase, which is basically a growth phase, and that enables or prepares it actually for the next phase, the mitosis phase. That's M. Where you actually divide the yeast into 2. So this is simply the overview of a budding yeast cell. So you start with one, and then you end with a new one. And this cycle goes on for every yeast, which also explains an exponential growth. So this new one that has been formed also goes into this cycle again. So this is what happens in the fermenter. And the way we know how to control this cell cycle because we apply a fed batch system. So in a fed batch system, what you do is you constantly add substrate. So we start obviously with a batch, like all you brewers. You add yeast and you just wait, you let it grow. And in our case, we add oxygen, of course, to prevent any ethanol production. But we just let it grow. And at a certain time, we switch to fed batch. And then we start feeding it with a specific composition, which is strain dependent, to bring to shape actually the yeast physiologically. And then at a certain point, we can stop or adapt actually this fed batch, this feed composition, to make sure that all the yeasts are in this G1 phase, which is the optimal phase for growth, so for fermentation later, but also for drying. In this phase, you also have a lot of trehalose produced, and trehalose are sugar units that help you to protect the yeast when you dry. So this is a sugar that will create a kind of layer around the yeast cell or around a bunch of yeast cells to protect it against rehydration, actually. What happens in addition is you produce a lot of sterols in this cycle. And during this phase, when we harvest, the amount of sterols is the highest. So we have quite flexible membranes. And I will show you a picture later to show you, what happens if you dry yeast. You basically you squeeze actually the membrane. What also is very important in this harvesting in this phase is that we have the doors, as we call it, for sugar assimilation are open. So all the transporters for sugars are open and stabilized. So both stabilized by the sterols around it, but also by the trehalose. And then we can go for drying. So if the yeast is in this optimal condition, so optimal composition, we are ready to go to dry. So I will now show this. So this the first step in drying actually is we dry it over a vacuum filter, and I will show you a picture of that. So it's are like big drums, and these drums in climatized sterile rooms, so you cannot enter these, you can only look through the glass. And what we do is we spray a layer of starch on it, and then we spray a layer of yeast on it, and we pull vacuum through a system of tubes that are, you don't really see it very well, but this whole surface is vacuumed constantly. So we spray on the yeast, Then it's sucked dry, like if you do a vacuum filtration at home, or even if you don't have it, if you put coffee in, and if you would suck it, you understand that you suck the coffee dry, like in a normal coffee filter. Then what we do is we scrape off the yeast that we sprayed on. So this thing cycles for some time. We spray on the yeast, and then when it's dry enough, say up to 20% dryness, we scrape off the yeast layer, and that's collected then and extruded and further processed. So this is how that looks. It looks like stuff to clean your windows, like cloth. It's very thick. In Dutch we call it a zeem. I don't know how you call it in Swedish. If you wash the windows. Jonas, obviously.
The cloth itself.
Obviously, you never wash the windows.
Yeah, I do, but I was thinking about what you mean.
Probably it's like a rubber. It's like a rubber, it's a natural.
Vad heter det? Fönsterskrapa.
Okay. Yeah, I trust this is the right explanation. I don't speak Swedish, so I have to trust you on this.
Våtskrapa, somebody says there. Yeah, sorry.
So, in short, we start in the laboratory, then we do fermentation, centrifugation. We have a short storage, rotating vacuum filtration, and then drying. And we start always with a pure culture. As I explained, fat batch process. We do aerobic conditions, and then this is the most important thing I want to mention is that we stop the propagation at the optimal moment to shape the yeast, physiologically, as I explained with sterols and trehalose, and this is needed both for drying but also for the fermentation afterwards. So you have all the membrane proteins related to sugar assimilations are ready to go. Also important to mention is that each yeast has its own dedicated process. So for the 14 yeasts, brewing yeasts that we are making now, we have 14 different processes. Each process is optimized for each yeast, so we are sure that when you start using it, what to expect. I see some chats coming in. Vatskapra, and that's the thing to clean the windows, probably.
Yeah, sämskinn is the Swedish word for it.
Okay, sämskinn. Thank you. Yeah. Thank you, guys. So if we look at the process under the microscope, so after centrifugation, the yeast still looks like this. It's a nice rod-like shape. This one is budding, you see, or it has been budding. You see a bud scar here. It's around 25-30% dry matter, and it's very smooth, as you can see. It's blown up. It's filled with water. Then, if you start drying, you see that the surface changes. It kind of wrinkles in, like if you have dried fruit. Everybody saw dried fruit. It's similar. So you see that it wrinkles. So in this case, and this is amplified 6,000 times, so that's why we can still see it. It's around 95% of dry matter. So both the water that is surrounding the yeast, but also the water that is in the yeast has disappeared, or a lot of the water that was in the yeast has disappeared. If you open a pack of brewing yeast, you see kernels like this. Well, you don't see this because this is amplified 26 times. But you see this kind of powdery, like granulates, and one contains millions of cells. And then we vacuum pack it, of course, as you know, to preserve oxygen and moisture from getting in. And especially the last one, moisture is something that you have to prevent. If I don't know how many of you have tried to store some yeast in the refrigerator, dry yeast. if you leave the pack open, you end up with like a marmite-like substance. Marmite, the stuff the Australians put on the bread, which is like a yeast extract. It smells horribly, and it goes very fast. Like if you put it, once I was in the UK, and I had a box of samples ordered. I was at an exhibition, and it got wet apparently on the way because I got a wet box, and I opened it and it smelled horribly. It was completely destroyed while it only took 1 day. So it's going very fast. If you cannot close your bag or your sachet properly, and I can assure you can't, because the foil that we use is aluminium plastic layered foil. It's multi-layer, so it's to make sure there's no light, no oxygen, there's nothing coming in. And all the vacuum machines that we can as brewers can have access to are the simple ones, the ones that only are plastic, and they let oxygen through, let air through, slowly, but it's happening. So if you split up yeast because you're not using a full pack, and you're able to vacuum it and put it in a refrigerator, you can still use it, but you will see the performance going down like in months. I do it actually as a home brewer, so sometimes I split up and then I leave it, but I noticed after like 4 or 5 weeks your performance is going down, and which means you can, if you want to compensate for that, you just have to pitch more yeast all the time. So the best thing is to always start from a new pack. That said, let me explain you a little bit on the quality, and I will show you the quality of our yeast later. So we start with a yeast strain, and that comes from Le Saffre International R&D, so the safe. We have a few safes actually around the world to make sure that we can keep everything safe in collection if something happens to our freezers. But if we start a production, we call International R&D, we need this yeast, so they will send us the yeast. It comes from the R&D collection, and then it's propagated and enters into the industrial collection. From that, it's further on propagated, and it ends up in a daughter cell line, and this cell line goes to the factory. And what we do in every step is we check genetics, purity, and properties. So genetics, what we do is we do a so-called identity check. So it's called interdelta PCR, where we check specific regions of the genome of the yeast to make sure that we are having always the same yeast, and that it's genetically pure. So we know it's a pure culture. Then purity, so we check for contamination. Contamination, what we do is bacteria, pediococcus. We do that, for instance, with the MRS test. We check for wild yeast with the lysine method. We have a lot of quality controls actually in each step. And all of as soon as you go from one vessel to another, we do this. So in the end, when we are at the factory with the propagated strain, so these guys are in a test tube.
And Gino?
Yeah. Yes.
We have a question, and maybe you want to finish that slide, but we have a question from Kenneth regarding the different strains. He says that my favorite types of yeast are from the British strains. There are many to choose from selecting liquid yeast, but only a few dry yeast on the market, which in my opinion does not produce as good ales as the liquid one. Is it because of less demand from the brewers, or is it a more difficult making dry version of these strains? Would be fantastic with dry version of West Yorkshire, Essex, British, and so forth.
Yeah. A lot of these British guys use the same yeast actually. For different types of ales. So we have for instance, SO4 is a typical British ale yeast, and by changing your fermentation, so changing your wort composition or changing your fermentation parameters like temperature, pitching rate, or gravity, you can produce different ales with the same yeast. I already did a seminar on that for BE256, for W3470. We just have completed BE134, and we are doing this study for all the yeasts in our collection. So to answer your question, I don't know when this study will be available, but I know, because I also work in the UK, quite a lot of brewers are making different British ales with the same yeast, just by changing parameters. And as I explained earlier, and when I was showing this phylogenetic tree, we only take up a new yeast in the collection if we think it will bring additional value to the market. So as long as you can produce maybe 5, 6, 7 different types of British ales with SO4, we are happy. The reason is we can only produce tons. So for an ale, we produce 5 tons in one time. As a home brewer, you use 11.5 gram. As a craft brewer, you might use 20, 30, 40 kilos per fermentation. So for 5 tons, you need quite a lot of customers. So this it's more like commercially a commercial decision rather than a creative decision, I would say.
Yeah, we hope Kenneth are satisfied with that answer. We have Lars. He wonders if you can freeze the dry yeast to extend the shelf life.
I will come to that later. I will explain that. Yeah. I see my background changed for some reason.
Sorry?
My background changed. I saw.
Yeah.
For some reason. I don't know why. I'll try to restore it. Hopla. Anyway, so from the R&D facility, we get the daughter tube line that enters the factory, where we first have a laboratory phase where we do the propagation in the laboratory. There we do only purity control, because genetically we already did several tests to ensure that we have a pure culture with one yeast. So we need genetic control after that anymore. So from the laboratory, we go to the industrial phase, we produce biomass and dry it, and then we store it. And then at storage, so the biomass that has been produced, we do purity, composition, aging, and properties. So for properties, we look at things like vitality, so fermentation kinetics, how much CO2 are you producing over time? It has to be a minimum value for the yeast that you are growing. We look at aging, and I will show actual results on aging in this presentation. So all yeasts are put in force aging experiments to see how well it developed, to make sure that we have the best before date that we promise. Obviously, we look at the composition, so the biomass content, the nitrogen content, the phosphor content, etc., and also the purity, because here also it's important to guarantee the purity that we put on the package or put in the spec sheet actually. And then it goes to you, or actually it goes to Humlegardens, and you purchase. It gets redrawn. It will never be put on the market. Just to to indicate. Sometimes we get complaints, not that much, about contaminated yeast. The chance that we put a contaminated yeast on the market is very, very low, because we did so many checks up front and also after the yeast has been produced. And during the production, we take several samples from the production line, so we know, from start to finish, exactly the composition of the yeast. And if we find a contamination, or if we don't comply with the specification, we don't put it on the market. The batch will go to cattle feed. So talking about ale yeast, the quality of ale yeast currently, this is for ales. Microbiologically, the characteristics are shown here. So we produce 10 to the 10 viable cells per gram of yeast. So it's 10 billion cells per gram. And we do have some contaminations. And as I explained, in the final production step, we cannot do sterile filtration because the amount of air that we need to grow the yeast is too high. There are no filters, sterile filters big enough, actually, that enables this high flow. So we do deep filtration, but we still manage to get quite good numbers, because for lactic acid bacteria, we have 1 bacteria per 10 to the 7th yeast cells. So practically that means, if you pitch 50 gram per hectoliter, we have less than 1 bacteria per mil. So this is actually below detection limit of all the tests available. For Pediococcus, it's the same. Total bacterial count is maximum 5 cells per 10 to the 7th yeast cells, so 10 million cells. Wild yeast, similar count, less than 1 per 10 to the 7th yeast cells. So if you calculate it back, our purity is 99.999%. Suppose there is 1 LEB in your yeast pack and you pitch the yeast, will it be a problem? No, because you have 10 billion cells that are ready to grow and want to consume the sugar, against 1 bacteria that also wants to consume the sugar and grow. But because of the high number of yeast, the single bacteria that could be in there does nothing to your beer. So what about lagers? The quality that we produce, I don't know why this is here. It's quite annoying. Maybe it's my internet connection.
Probably.
Let's go back. I was at 18, I think, or something. Apologies for this. I will talk to the technical team. Yeah. Well, this is not me, guys, clicking. I'm not doing anything. It's just moving. I'm not sure what's happening.
When we're waiting for the slides, maybe I could mention, you mentioned earlier the tips and tricks that was able to be downloaded. But you also have an app, which I find very useful. So especially if you want to see the different difference between the different yeast in taste and aroma, I could fully recommend the Fermentis app. It's downloadable for free on App Store and what other stuff.
Yeah, I'll mention that also at the end.
Okay.
And show you, yeah, but just in 2 slides. This is very annoying. Ale. I'm a bit afraid to click any buttons. Lager. So for lager, I hope it stays on this page now. The viable yeast cell count is a bit lower. It's 6 times 10 to the 9. So it's 6 billion cells. It's still a high amount, but lagers are a little bit more sensitive in the production. In terms of presence of bacteria, pediococcus, total bacteria, it's quite similar to the ales. Especially if you think of, you add also hops to beer, you have alcohol, so these bacteria will not be able to grow in optimal conditions anyway. If you pitch at 100 gram per hectoliter, because normally lager you pitch a bit higher, you end up with the same purity as the ale, so 99.999%, which is at present the highest purity on the market, both for the ale as for the lager. Which is quite impressive, if you consider the volume that is brewed. We just had a question or a related question on the liquid yeast, because I get this question quite a lot. What is the difference between liquid yeast and active dry yeast? Some brewers, they say liquid yeast is the best there is. Obviously, we tested this, and I'm going to show some results on that. So this is USO5. I chose to show this because this yeast is used the most. This is showing the gravity over time of yeast that has been dried and yeast that has been harvested before drying. You can see, maybe the kinetics are a little bit faster, but in the end, in this phase, it's all the same. There's no difference in kinetics, fermentation-wise. And if you look at flocculation, also very similar. There's no difference for both the fresh and the dried yeast. And then most important, flavor development. So liquid yeast, these were all 11 brews. We did this with BRI, which is a British research institute for brewing, with an expert sensory panel, 35 tasters. These are the parameters we identified, or we use actually, on a scale from 1 to 10, or from 0 to 10. So, for instance, S3 was between 3.85 and 5. And then if you look for the dry yeast in both reference brew and the test brew, it's in the same range. And that goes for all parameters. So if you, conclude on the difference between liquid and dry yeast, actually there are no differences in fermentation kinetics. There are no differences in flocculation characteristics. And most important, also the aroma profile, including off flavors, it's all comparable. It's all in the same, error, in the same error range. So it's all in the same range. It's very comparable. In addition, you have some advantages of dry yeast, because long shelf life. I will go into that. You don't need oxygenation prior to pitching. The next webinar will show that a bit more. So you can pitch directly. You don't need to oxygenate your words. You can if you want. Dry yeast also has a way higher cell count per package. So if you pitch the same route, will need more liquid yeast. It's also a little bit more expensive, liquid yeast. But the big advantage of liquid yeast is that you have more strains available. But in the philosophy of ferment, as I explained, how many strains do you need to come up with a certain flavor? And we believe that by changing fermentation parameters, you can get similar flavors. In addition, for us, it would be, practical impossible to come up with such a big range of different yeasts because we cannot produce all of them simply on such a large scale. So there are some specific liquid yeast that we don't have and that you can also use, obviously. But commercially, obviously, dry yeast is more interesting because of the larger volumes. We can produce it more cheap. Some other advantages, of course, you don't need cell bank management. This is mainly for craft brewers that use propagation. If you start storing the yeast yourself in freezers, you have to know what you're doing. If you use dry yeast, you call the team of Humlegardens and you have it within a week or so. So it's easy. It's easy to store, and I will show that in the next slide. It's of course easy to use. Easy to use is a specific brand actually that we have a trademark on, which explains that there's no difference between rehydration and direct pitching in terms of all kinds of parameters. But I will do a webinar on that, so I will not go into detail. Last but not least, of course, the quality I just shown and fast fermentation start. I'm quite sure that most of you that have been using fermented yeast should be, quite happy. I brew myself quite a lot, and if I pitch the yeast, normally I never had one that was not going. So now, how long can you store the yeast? I see there's a question coming in. Yeah, about LA01. I do a webinar.
Yeah, we could mention.
We will do a webinar on LA0. Oh, you mentioned that. Okay. So how long can the fermented yeast be stored? So how do we decide on the best before date that you find on the package? So we did a lot of studies on that, and I will show you the results. We do it in two different ways. We do a force aging test, which is a special cycling test where you cycle the temperature and the time. So you put it at a high temperature for a certain time, then you put it at low temperature for a certain time, then you put it back at high temperature, or sometimes even a higher temperature or somewhat lower temperature at a certain time. And this is it's called a force aging test, and it basically mimics a normal natural aging in time, but you can do this obviously way faster because you're increasing the time, increasing the temperature. So what I will show you is the difference in viability, performance, and also analysis on the volatiles, ethanol production of fresh versus aged yeast. I will not show all the details from all yeast, but I will show a few. So this is an example of the forced aging test where we start at year 0 with 100% viability, and then 2 years, 3 years, and 4 years of forced aging, which is the equivalent in natural aging. And you see it's going down a little bit over time. So this is for SO4. This is 5 replicates. If you look at the kinetics of ethanol production of these 5 batches, you see, you have here the curve, and you have, this is the confidence interval. So 95%, you can be sure that you follow this curve. This was done at 50 gram per hectoliters in Weirman, Wort 15 Plato at 20 degrees. And then if you combine them, or look at aged first, probably. Yeah, for aged, we did something similar. So this is aged for 4 years, force aged. You have a similar curve, and then if you put them on top of each other, you see the red one is a little bit behind at the start, but it recovers again at the end. But you see a little bit of deviation after 4 years. Then lager, and this is showing W3470. I'm now showing both the fresh in blue, so year 0 and year 4 in the same graph, and there you see bigger differences. You see that the forced aged W3470 is slower than the fresh one. But in the end, when you have a lot of biomass, it picks up again. But we see differences, not big, but it seems a bit slower. So then, if I look at all the strains of our normal portfolio, so SO4, USO5, WBO6, S33, T58, B256, and K97, and look at the total fermentation time of fresh versus 4 years of forced aging, then you see, it's comparable. This is comparable. This is the same. They are all the same, because you have to incorporate these, errors that you get from the repetition. So that statistically, there is no difference between fresh and 4 years of aging. For some, you might see some trend like K97. It seems like there's a, if you look at the ethanol production per day, you see it's a bit slower or a bit less if you have a 4-year aged yeast. So this yeast is already 1 year past date. And this is our ppms. You see there's no difference in fresh versus aged. Ethanol, the final ethanol, final attenuation, exactly the same. Higher alcohols, exactly the same statistically. Yeah, you might see a little bit of difference here in USO5, but in general, the difference between fresh and 4 years is very, very small. Which means, if you are paying attention, our best before date is 3 years to ensure that we always have the quality that we want. But if you look in your fridge and you find an ale yeast specifically, that is a year past date, you can still use it. Just pitch a little bit more if you're doubting than usual, but you will end up with exactly the same result in terms of beer. For lagers, very similar results. So ethanol content of the beers. So this for S23, this for W3470, this for S189 is very similar. Ester production, very similar. The ethanol, the productivity per day, you see a little bit, going down for 23 and 3470 and a little bit going up, but this is a trend, because if you consider the error bars, statistically there's no difference between all these. Also for the higher alcohols, which is quite good news.
We have a question from Patrick. We had a couple of batches where we're using SO4 and USO5, where we had lower attenuation, even though we had the same OG. roughly the same pH, mash temps, etc., etc. Have you had any batches recently that attenuates a bit less?
Not in my zone. What we normally do is you have to send me an email if you have questions like this, and send me as much information as possible. In particular, also on dosing of hop, dry hop doses, and also addition of strange compounds, because I had several complaints from people that in the end were adding some chili pepper in high amount to the beer, and obviously the yeast could not handle that. But this is such a specific question. It's better that you email me, and then I will look at your data. I can access. I can send it to our technical team. They will look at it. I can get all the documents required from quality. So normally, and that this is important for all you brewers, if you use a yeast pack, if you have a folder where you store your brew data, please, and make sure that you write down the batch number. If you're a home brewer, make sure you save the sachet, write down the batch number and the complete number, because with that I can trace it back completely to the guy that has been running in production, and so we have the full analysis available. Without a batch number, we have to work from best before date, and we produce several batches per yeast per year. So that's a bit hard. So if this is important for you all, please write down the batch number, because then I can help you the best as possible.
Yeah, I think Patrick is happy with that. He says, "Great, will do."
Okay. So force aging conclusions. It's very robust over 4 years. Very similar performance. We say the best before date 3 years. The reason is actually is mainly depending on the lager, because for the lager we see a little bit more of a trend. It's statistically there's no difference, but we see a bit of a trend. It's slowing down a little bit after 4 years of aging, so that's why the best before date is 3 years. And to ensure and just to simplify it, we put the best before date of 3 years on all our yeast. But as mentioned, if you have an ale yeast, of 4 years old or even 5 years old in your refrigerator, and you're doubting to use it, trust me, you can still use it if you stored it under the right conditions, of course. And I will come to that now.
Oh, okay. Or should we have an additional question? I'm not sure if we have the time, but we have another Patrick. One dry hopping, if it's killing yeast or making it life hard for the yeast.
Yeah, it's the latter. It's making well, partly it's making not the life hard, but if you have extremely high hop dosing, and what is a high hop dosing? It's like, I think everything above, say, 1.5 kilo per hectoliter is high hop dosing. I had brewers that were dosing 3.5 to 4 kilos per hectoliter in dry hopping, and what you see then is sometimes you get a second fermentation based on the sugars and the enzymes present in hops. It's this thing is called hop creep, where you actually shortly restart the fermentation again because of this high hop addition. And the big downside of this is that you are able to produce off flavors in this short phase, and because you are at the end of fermentation, it's very hard to get rid of. Like if you produce diacetyl, for instance, during hop creep, yeah, you can throw away the beer because or wait forever or a long time to get it out, and so that's why I always ask for a hop dosing. If you add, other specific, like, you craft brewers are very creative. I love it, but some people throw in strange things in beer. Not everything is, useful to put in beer, like extremely hot chili peppers. I know a lot of people in India like it, just to eat it. But normally, if you put it in beer, a lot of organisms don't like that. We unfortunately don't have data on all these additions, and maybe in the future we will have. Some additions are more. We are working on hops, for instance, and hop yeast interactions. So I will do a webinar on that. Actually, it's very complex, but we are not working on addition of herbs or or individual herbs, because you have many different herbs, and if you look in herbs and also in hops, you also have a lot of influence on the terroir of the hops. So even if you have a cascade from the US from a single field, if you have the harvest from the left side of the field, it can be completely different than the harvest from the right side. So it's very complex, as a fermentation company, to go into those details, because most of you guys don't use a single hop. Most of you guys use 3 or 4 different types of hops, and then depending on the beer, maybe 3 different hops in the dry hopping. So that overcomplexes things tremendously, because our business is fermentation only. So to come up with solutions and answers to questions like that is very complex. So we are working on that, and I will show. Well, I showed already some things on that on the New England IPA seminar before. I'm preparing a webinar on yeast and hop interaction, because we see that some of our yeasts interact differently with, for instance, cascade hops. You get different flavor profiles at different conditions and different dosing. So in the New England webinar, for instance, I showed that some yeasts are able to extract more hop oil than other yeasts, based on the same word. So it's a bit unexplored territory, but we are working on that. And all that we know, we share. So as soon as I have good data available, we will do a webinar on it, and to share it with you. So then storage temperature, I just got this question, and what does it do to the yeast vitality? So basically, store it cold or store it hot. Not that hot, I would say, but so we also did natural aging, big study. So in this case, no forced aging. We just, this is a long-term study. It's still running, where we again look at viability, fermentation performance, and tasting. So sensory analysis. And in this case, I have data that I can show you now of 3 years and 8 months. We are already a little bit further, but I couldn't get the latest points. So I will show you the difference between fresh stored at -20 in the freezer, stored at 5, and stored at 25 degrees. So first SO4 again. So year 0 in this case is fresh. It's 100% viability. Then if you store it for 3 years and 8 months at -20, you have around, let's say, 98% viability. Stored at 5 degrees, you have around 94, and then at 25, it's quite similar, 94 for SO4. If you look at the kinetics, so fresh versus stored at these different temperatures, you see there's no difference in kinetics. They're all the same. And this was done on 15 Plato malt, again, Weyermann, at 23 degrees, 50 gram per hectoliter pitching. So no difference. It's quite boring, but it's actually quite good news, because apparently you can store it in all kinds of conditions without really affecting the fermentation kinetics. Then sensory. So here this is a spider plot, and here are the typical flavor descriptors. I think most of you have seen these plots before. So take one, for instance, fruity. You see that the fresh one seems to be a little bit more fruity compared to if you store it at 5 degrees, if you store it at 25 degrees. spicy, but very similar. I mean, the scale is from 0 to 8, and you see the differences here are very, very small. So it's very comparable. You could say maybe the sweetness is a bit changing, and fruitiness, but overall it's very similar. Maybe at 25, you see here some deviations, a bit more cereal, a bit more toasted. So the higher temperature seems to be a little bit less optimal if you talk sensory. Then the lager, I'm showing here W3470. So we did this for all the yeast that we have. Again, year 0 is the fresh one, and this is stored at -20 for 3 years and 8 months. That's stored at 5 and stored at 25. And here you see bigger differences. Like if you store a lager yeast, if you put it in the freezer for 3 years and 8 months, you see you have only 80% viability left. While if you put it in a normal refrigerator, you still have 95 viability. So obviously the lager yeast, is having a harder time getting. That said, 80% viability is still quite nice. At 25 degrees, it's not optimal at all. You see, we drop to around 58% viability, which is about half of what it's normal. So high temperatures are not optimal, but it's also kind of expected because lager yeast, as you all know, it's a hybrid between Eubayanus and Cerevisiae. So this is the Eubayanus is a cold tolerant yeast, so it prefers cold. That's why we do normally cold temperatures in lager fermentation, because it likes lower temperatures. So if you put a lager at higher temperature, it doesn't really like it. At least if you store it for 3 years and 8 months.
So to sum it up, the fridge is the best place to have the yeast in.
Yes. This is just to conclude the difference in kinetics. As you see, the fresh is the fastest, and then at 5, -20 and 25. So you see the 25 is really slower. And if you look, also the angle is changing a little bit of this. So because if it would be the same, it would just be a matter of the amount of yeast cells. But this is actually also showing that it's actually slower. It's slowing down, but it's still working, as you can see. In the end, you almost reach the same final gravity. So the question is, what does it do to the flavor? Again, a spider plot, and also here you see at higher temperature, so stored at 25 degrees, you have a lot more sweetness in the beer. So it doesn't, end up as low as you would like it. On the other hand, you get more fruitiness, which is also a little bit expected, because normally at somewhat higher temperature you create more fruitiness. So metabolically, this can be explained. Overall, again, the differences are not huge, sensory-wise. It's you really need an experienced panel to taste. Are shown here. Most people will not taste this. So overall, I'm getting to the end now. I'm already talking for a long time. Sorry, guys. Final conclusions. Well, I know our yeast is the best on the market with a purity of 99.999%. No other dry yeast producer has this quality standard. As I showed, no differences between fresh and forced age yeast. Also no differences, or almost no differences with the natural aging. A little bit for the lager. So indeed, as Jonas mentioned, storage and cool. So say, in the refrigerator between 0 and 5 and dry conditions is what we recommend. the production of all these the esters and the higher alcohols is not really affected. As I also mentioned, you should not use a pack that has been opened, or use it quite quickly. And something I did not show is that direct pitch is not impacted by aging. That's how we got the easy to use certification, but I will show that in the next webinar. As Jonas also mentioned, we have Fermentis app. These are just some screenshots. If you download it, you can get access to all kinds of data that we collect during the year. So that is not ending up in the tips and tricks, which we only update once a year. And you can do all kinds of calculations, like and select your yeast. If you say, okay, I want to make a blonde beer, it should be a little bit dry. You click on the things that you want, and then the app will recommend a yeast for you. You can also find some data. So, for instance, if you click on make your choice, you will see this, and then you can click these blocks and get additional data. I will show that. Oh no, I will not show that. I removed that slide, sorry. But you can get data like, okay, what if you put W3470, for instance, at different temperature or different pitching rates, what does that do to the sensory profile of your beer? So there's more information in the app than you initially would think. It's a great tool. So this is the slide actually I showed at the start, the webinar cycle. This was the third one. The next one, I will discuss with Jonas what would be the best topic. But we will announce it, I think, 1 week or so, 1.5 weeks in advance. But these are things that you can expect at least in the coming 2 months or so. If you want me to repeat any of the others, just let Jonas know or let me know, and I will do it again. Last but not least, this is also an important one, your topics and ideas. If you want me to work on something that, specific, just let me know. And you can do that by completing this questionnaire. And you will be guided or transferred to a forum. You can also use this. I'll check if I can. I'll find the link in the original presentation, because I had to. I'm looking on my computer now, because I had to put it on a PDF in this edu system, edu-dip system.
Yeah, maybe you can post it in the chat.
Yeah, I will. I'm just going for the link in the original PowerPoint presentation, because what I'm showing now is a PDF, because the PowerPoint was too big to upload.
We had a couple of questions here regarding the LO1 and also the LP652. And yes, you do have some seminars on those, but the thing is, it's not available in consumer packaging yet.
Oh.
I think the LO1, for instance, will probably not be available for consumers. It's more a professional brewing product.
And the reason I explained, the reason is that we cannot pasteurize as small brewers. But it's a marketing decision. I mean, if you make sorry, go on.
No, I was just thinking loud. If we could do the webinar, but as a home brewer, I'm not sure if it's useful to hear information about a product that you can't buy.
Yeah.
So it's a bit of, yes, that could be an idea. So yeah, we'll see how we handle those webinars. We have another question. It's Patrick Hellström who asked, in an earlier webinar, you looked up time of attenuation on different yeast when talking mixing yeast and percentage to use. And you looked it up in a book. What book was that? Do you remember?
Yes, it was this. The tips and tricks. How strange is that?
The tips and tricks.
The background from this guy is
It
disappearing.
disappears.
I see it. It's in the tips and tricks. So I will show you. I'm not sure if I can. I'll show it in the book because I'm afraid to click in the presentation. So if you look in the book, it's not showing it. Let me change my background.
He says he will download it later on.
Yeah, so what you will see on page 28 is this, fermentation curves, different kinetics. So you can calculate actually the growth rate and then base the ratio of addition on the growth rate. So if you have a yeast, for instance, SO4 compared to USO5, so SO4 is growing about, I don't know, 40% faster than USO5. If you want to pitch both yeast and have a 50-50 flavor addition of both, then you need to add more USO5 than SO4, about 60% more USO5 compared to SO4. On the other hand, if you want to have more or just a little bit of another yeast, so say, okay, USO5, I only want 20% addition of the flavor compared to the SO4, you just pitch a little bit less. If you have a very high gravity, so if your fermentation takes longer, then the yeast that is growing faster has always the advantage. And you know, these curves are exponential. So if you pitch 10 billion yeasts of one and 10 billion of the other, but the other is growing, you know, twice as fast, in the same time you will have 40 billion of one and only 20 of the other, and then 80 of the other and only 40. So you see this difference grows very, very fast. So the only way, if you want to have any control, is to do a ratio on the beginning, because what some brewers do is they pitch a second yeast later, and I also did that before myself. I also tried that, and what I found is that most yeasts do not start up if they don't have a primary sugar available. So only a limited amount of yeasts are able to start up on you know, a limited amount of maltose or on maltotriose. It's not, almost none do that. Because some brewers say, okay, I had a, you know, SO4, we just had a question. We ended up with a little bit lower attenuation. So, you know, why not add a second yeast to finish it up? But unfortunately, that doesn't work, because even if you would pitch a yeast, you know, that has an attenuation of 95%, it will not start up because it needs primary sugar, or most of them needs like a primary sugar to start up.
Okay. I don't think we have any more questions for the moment. We have overtimed a bit, 45 minutes, something like that.
Yeah, sorry. Part of it was technical problems.
Yeah. For coming seminars, we will communicate which topic it will be on social media, at least on Facebook, and I think we will also do a mailing to the ones who have a subscription of a newsletter.
Yeah. Okay, sounds great. Well, if there are no more questions, I see two people typing.
Yeah, they are typing.
You're welcome.
Thank you.
Thanks. I'll try to sort out the technical issues next time.
Yeah. But I think people seem to be happy anyway. So, and thanks a lot, Gino.
You're welcome.
We probably see each other soon, I hope.
I hope so too. Probably next week or the week after. Okay, thanks.
Yeah.
Thanks, guys.
Thanks. Take
Bye.
care. Cheers.